Okay, so good morning, everyone. So this will be our last lecture for optics and for physics 72, and this will cover interference from coherent sources and thin films. Okay, so interference is a phenomenon in which two or more waves overlap in space, as we can see from this animation. And here, one of the key properties of waves are put into action. It is the superposition of two waves. Okay, so we can see they either add up or subtract their amplitudes. And interference pattern is typically seen in swimming pools or puddles, or wherever you see some ripples around, as they are produced caused by a disturbance in the medium. Okay. So actually, kahit sound waves, may interference pattern, hindi lang natin nakikita kasi hindi naman visible sa atin yung air, for which the ripple pattern could be visible. However, um, some experiments showed that light also exhibits interference patterns. So they can also be observed in some controlled environments in the lab, such as the famous two-slit experiment by Young. Okay. And this interference pattern is not just in planar, they can also be observed in 3D, as shown here. And we can see clearly the waves produced by adding the crests of two sources, okay, in here. And when they subtract, when each of these waves subtract, so wala ka namang makikitang crests or troughs. Okay. So by closer inspection, we can show which regions produce constructive and destructive interference. So here, where crests and troughs are produced, kung saan yung may parang ripple effect, nandun yung constructive interference. And then sa other side naman, merong destructive interference. Okay? So, the total wave disturbance at any point and at any instant in time can be determined by using the principle of superposition. Okay. So for example, we have here two waves. To produce a constructive interference, okay, constructive interference, we line them up with each other, kung saan sila nag-start. And then if their crests matches with the crest of one wave matches with the crest of another wave, as well as the troughs matches as well, then we say the waves are in phase. Okay? If the waves are in phase and we add these two waves, we get a new wave shown here in black line. Okay? And this new wave has a higher or a bigger amplitude than any of those two waves that used to be added to produce this. Okay? So amplitudes add for constructive interference. For destructive interference, again, we have these two waves, we line them up. Okay. And if we, after aligning, we see that the crest matches with the trough. So the crest of one wave matches with the trough of the other wave. Okay. So in this case, the waves are now out of phase. Okay. Out of phase. So kanina in phase, ngayon out of phase. Hindi sila, walang similar phase difference sa kanila. If we add them up, actually, amplitudes cancel out. Okay? Kasi nga, nag-add ka ng positive A, yung positive amplitude, and a negative A, which is a negative amplitude. So, plus A minus A, 0. As well as on other points. Okay? So, kung dito sa gitna, may plus A over 2, dito naman may minus A over 2, pag inad mo, 0 din yon. So, destructive interference, kaya siya destructive, nawawala yung wave, nade-destroy. Parang ganon. Okay? So, wala ka ng amplitude. So, amplitudes cancel out. Okay? Now, if we have two beams or two sources of light or EM wave, and they are to interfere to produce a stable pattern, they must have very nearly the same frequency f. Okay? So again, si linear frequency f yung magmamatter. Okay? And nangyayari lang yung nearly the same frequency f in monochromatic light. Kaya siya monochromatic. Mono means single. Chroma means color. Single colored light. So this monochromatic light is any light with a single frequency f. For an example, such lasers. So meron tayong, kaya sila monochromatic, single color. Okay, meron ka lang purple laser, blue laser, red laser, green laser, etc. Some not examples of monochromatic light are white light sources and incandescent bulb. So may kahit na incandescent bulb mukhang yellowish, sa gitna niya yung pinaka-source ng light, white yon. Okay? So since white is composed of all the colors, present lahat ng colors, then hindi siya monochromatic. It's non-monochromatic. Okay? And other white light source actually is the sun. So again, sun mukhang yellow pero sa gitna, huwag niyo nang titingnan by your eye. White yon. So again, it's composed of all the colors, a mixture of all these colors or all these frequencies, F. Okay. So if your source has only one frequency, we say that source is coherent source. Okay. Sources of same frequency F. Okay. So kung meron kang dalawang source, parehas yung frequency nila, then they are also coherent with each other. They cohere. Okay. And this means that they have a definite constant phase relationship. Meaning, pwedeng ang phase difference nila is 0, pwede ring 2 pi, 4 pi, etc. Okay. So some examples of coherent source is this. Okay, so meron tayong single coherent source, yung black dot in the center. And it produces these ripples or waves across the medium. Okay. Where the thick lines represents the crests ng mga thicker green lines. And yung thin lines naman is yung troughs. Okay, thin lines naman itong troughs. Okay. Now, if we obtain a cross-section of this medium, we see yung typical wave na alam natin. Okay. Dito ay crest, so crest yan. Sa gitna ay trough, so trough naman yan. So kailangan mag-align. So this is also crest. This is also a trough. Ito yan. And then this is also a crest. So we see na kailangan meron ding crest dun sa source. Okay. So pwede natin kunin yung any slice of this source in two dimension. These are called circular wavefronts. Okay. So again, kung kunin mo yung cross section, magiging line lang siya, itong wave sa baba. Itong wave sa baba. Okay. But this represents these 2D circular wavefronts. In 3D, pwede rin namang 3D ito, spherical wavefront naman siya. So isipin nyo para namang siyang sphere na nagpo-propagate outside. Okay? And if you also get the cross-section of that spherical wavefront, same lang yung magiging representation. Okay? Now, let's see. Ano ba nangyayari kapag we have two coherent sources of waves? Say S1 and S2. So si S1, siya yung source of green waves here in this figure. And si S2, siya naman yung source ng blue waves. Okay? Of course, merong noticeable interference pattern. Medyo maganda yung pattern, like pretty pattern. Okay? But let's see. Let's analyze more. Kailan nangyari yung constructive and destructive interference? Okay? So constructive interference again occur when the crest of one wave meets the crest of another wave. So, pag yung crest to crest yung nag-align. So, for example, in point P, so, okay, consider the paths. So, if your point P is located here, kung nandito ka sa point P, consider the paths R1 and R2. Okay? Si R1 and sa R1 muna. So, si R1 from the source S1. Okay? So, R1 na to, so again, kunin natin yung cross-section as we traverse from S1 to point P. Ito yung makikita natin. So, kay S1, crest siya. Okay? So, crest siya. And then may trough, and then crest, trough, crest, hanggang kay point P. So, ilan yung crest na nadadaanan mo from S1 to point P? So, bilangin natin. That will be 1, 2, 3, 4. Excluding yung point S1, of course. Excluding yung source. So, if i-drawing natin, 5 yung crest, including the source. So, including the source, meron kang 1, 2, 3, 4, 5. So, 5 crests. 1, 2, 3, 4, 5. So, ganyan mo siya i-drawing. Ngayon, bakit siya 4 lambda? Kasi ang lambda is yung wave length. Siya yung length of one crest to the other crest. So, from point S1 to the next crest, 1 lambda lang yon, di ba? Tama? So, parang 1 meter, di ba? Parang gano'n. 1 lambda lang yon. So, from here to here, 1 lambda lang yon. Okay? So, from here to here, 1 lambda. Ganon din dito, 1 lambda. So, meron kang 1, 2, 3, 4 lambda. That's why yung R1 natin is 4 times the wavelength. Again, R1 is a distance. Wavelength is also a distance. So, by dimensional analysis, okay lang, pareha silang distance. Okay. Now, consider R2 from point S2. So, kung meron kang another source, S2, ano naman yung distance nito from point P, from your location? So, bilangan natin ngayon yung lambda. So, that will be 1, 2, 3, 4, 5, 6. Now, do we have 6 lambda or 6 times the wavelength? Okay. Yung length from S2, from the source S2 to your location, point P, is 6 lambda. Okay. But in total, meron kang 7 crests, including the source. Okay. Now, again, naka-line up na sila. I-add ngayon, or i-subtract ngayon natin. Okay. Kunin natin yung absolute difference. So, this is the path difference. So, if you take two paths, if you take the absolute difference, so, meron kang dalawang path, R1 and R2, subtract mo sila, kunin mo yung difference, and then take the absolute of that, we have the path difference. Okay? So, ngayon, magsa-subtract, so magka-cancel out to mga to, ang may iwan lang is this part, which is just 2 lambda. Okay? So, para ka na lang din nag-subtract 6 minus 4, 2 lambda. Okay? Or 4 minus 6 is negative 2, but absolute value, so 2 lambda. Okay? So, that is your path difference for constructive interference. Okay? Now, we take another point P. Kung nasa ibang location ka naman, ito naman yung R1 mo. So, meron ka ngayong 5 lambda. 1, 2, 3, 4, 5 lambda. And from source 2, meron kang 1, 2, 3 lambda. So, kunin natin yung absolute difference or path difference, we also get 2 lambda. From another point, okay, 5 lambda from source 1, 5 lambda from source 2. So, yung absolute difference is 0. So, we can generalize these 3 results. So, in general, yung any path difference, kapag meron tayong 2 coherent sources, any path difference will produce a constructive interference provided that this path difference is equal to m lambda. So ito yung condition for constructive interference. Okay? So yung R1 is again distance from your source to any point P. R2 is your distance from the source S2 to the same point P. And M is any integer. Okay? So dapat yung path difference integer multiples of the wavelength. Yun lang sinasabi nito. Okay? To produce a constructive interference, yung path difference from two sources should be integer multiple of the wavelength lambda. Okay? So, meron tayong condition for constructive interference. How about destructive? So, how do we know if these two waves produce a destructive interference, or when or where? Okay? So, again, destructive interference occur when the crest of one wave meets the trough of the other wave, or vice versa. Okay? So, let's see. So, let's say this is our point P. Okay? So, R1. So, bilangin ngayon natin ano yung lambda. So, meron tayong 1, 2, 3, 4 lambda. From source S1, siya yung green. Okay? From S2, we have 1, 2, 3, 4.5. Okay? So, 4.5 times the wavelength. If we take the path difference, mayroon tayong may iwan na 0.5 lambda. Okay? Now, from other point, so S1 will be 1, 2, 3, 4 lambda. S2 will be 1, 2, 3, 4, 5.5 or 5.5 lambda. Take the absolute difference, we get 1.5 lambda. Okay? So, another point, this will be 3.5 lambda. From R2, we have 3 lambda. Absolute difference will be 0.5 lambda. So, I think medyo obvious na ang condition for destructive interference in general should be a multiple of m plus 1/2. Okay? To produce destructive interference. So, kung constructive, kung yung path difference ay integer multiple, so m lambda lang, constructive interference. Okay? Kapag m plus 1/2, then destructive interference. Okay? So, yun lang yung difference nun. Okay? So, these are the summary for your conditions for constructive and destructive interference for coherent sources. Okay? So, again, for this to hold, the two sources must have the same wavelength lambda and constant phase relationship, meaning coherent. Okay. So, true lang to for coherent sources. Okay. For example, two coherent sources, A and B, of radio waves are 5 meters apart. Each source emit waves with wavelength of 6 meters. Consider the points along the line between these two sources at what distances, if any, from A is the interference constructive and destructive. Okay. So we can draw the drawing muna natin yung problem. So distance between A and B is 5 meters and lambda is 6 meters. Okay. Yung wavelength of the both of the sources is 6 meters. So, para maging constructive, we apply yung condition for constructive interference, which is the integer multiple. Okay? So, pick any arbitrary point between A and B. So, yung R1 mo will be sa, let's say that will be X, right? Now, if the total distance from A and B is 5, then yung remaining will be 5 minus X. Tama? Para X plus 5 minus X is equal to 5. Yun yung total distance from A to B. Okay? So, if R1 is X minus 5 minus X, which is yung R2, kunin yung absolute value, that will be 5. Tama ba? 5 plus 2X, or hindi pala, 2X minus 5. Okay, so 2X minus 5. And then, konting algebra lang, and we get this. Okay, yung X equals 3M plus 5 over 2. So, isolate natin si X. Okay? So, again, lambda is 6. So, 6M to. Okay? Tapos, meron tayo ditong, sulat ko na lang. So, this left-hand side magiging 2X minus 5. Yung right-hand side is 6 lambda. Okay? So, ilipat natin yung minus 5 sa kabila, magiging plus 5. And then, meron tayong 2. So, divide natin siya ng 2. So, dito, x na lang, yung may iwan. Ito, i-divide mo ng 2. Kaya, meron ka 6 over 2, which is, sorry, m pala to. So, 6 over 2 is 3m. Okay? So, 3m plus 5 over 2. And then, x na lang sa kabila. Okay? Now, we apply or we plug in values for m. Again, m should be just integer. Okay? And if we plug in values for m, ito yung makukuha nating x. Ngayon, konti lang yung valid values for x. Kasi if m equals 1, x will be 5.5. Meaning, sumobra ka na dun sa distance ng A and B. Right? Kasi ang maximum distance lang is 5 meters. Of course, ang minimum distance should be 0. Kaya yung m equals negative 1, that produces x equals negative 0.5, hindi rin valid. So, ang valid lang is when m equals 0 and x will be 2.5 meters. Okay? So, this is the only point between A and B such that the interference will be constructive. Okay? Nakuha? Okay. Now, for destructive interference, i-edit lang natin yung equation. Meron lang tayong m plus 1/2. Okay, pick any arbitrary point. Actually, same lang naman yung magiging R1 and R2 natin. X and 5 minus X. Plug in our values and solve for X, we get this. X equals 3M plus 4. Again, M should be just integer na lang kasi nandito na yung 1/2. Okay. And plug in different values of X, we get this. So, M, when M is negative 2, so that will be negative 6 plus 4, negative 2 rin yung X. If M is negative 1, this is minus 3 plus 4, this will be X equals 1. M is 0, then we have 4, and if M equals 1, we have 7. Okay? So, again, meron naman tayong dalawang valid solutions. Actually, ngayon dalawa na. Yung negative 2 meters, hindi pwede kasi that is beyond the distance between A and B, as well as yung when x equals 7 meters. Sobra naman yon. Okay. So, dalawa lang yung valid solutions. So, only at x equals 1. So, kapag nandito ka sa point na x equals 1 and x equals 4, dun lang magkakaroon ng destructive interference. Okay? And then, constructive sa gitna. Tama? Gitna ba yun? 2.5. Okay? So, ganun lang. Check nyo muna kung ano yung mga valid solutions by plugging values for M. Another example. Two speakers emitting identical sound waves of wavelength 2 meters are in phase with each other. Okay? So here we have S1 and S2. Okay? They are 6 meters apart. And then an observer is located as shown in the figure. Okay? So una, R1 is 8 meters. Okay. At the observer's location at this point, what is the path difference for waves from the two speakers? Will the sound waves interfere constructively or destructively, or something in between? And suppose the observer now increases her distance by up to 17 meters. Ano ngayon ulit yung path difference and constructive or destructive ba? Okay. So first, letter A. Path difference muna in this example. Okay. So in this configuration muna. So the path difference, R1 is this. We don't know R2, but we can get it by Pythagorean theorem. Okay. So R2 is just square root of 6 squared minus or plus 8 squared. So ito yung R2 natin. Right? Minus yung 8 meters ng R1. Okay? So again, path difference to. So pwedeng R2 minus R1, pwedeng R1 minus R2. It doesn't matter. Kasi absolute naman yung makukuha, yung gagawin mo. Okay? So if we plug in our values, we get this path difference 2 meters. Okay? Ngayon, ano yung type of interference at that point? So, we can solve for M. So actually, gagamitin mo, try mong solve for constructive, try mo ring i-solve for destructive. But since 2, lambda is 2 meters, right? Lambda is 2 meters. So 2 to, yung lambda, 2 rin yung R1 minus R2, we get M equals 1. So integer multiple. Okay? So hindi natin kailangang i-test dun sa destructive. So here, constructive yung interference. If we try yung isa, yung sa destructive, so R1 minus R2 equals, ano yan? M plus 1 half over lambda. Ito naman yung sa destructive, di ba? Okay. M plus 1 half over lambda. Okay. And solve for M. So again, we know that R1 minus R2 is 2 meters. Tapos M plus 1 half. And then lambda is also 2 meters. Okay. So magka-cancel out to. And we have M equals negative 1 half. But again, yung M kailangan integer siya. So that means at this location, at this situation, hindi pwede maging destructive interference. Okay. So gusto ko lang ipakita na talagang constructive lang yung pwede mo makuha. Okay. So isa lang. So at any location, isa lang yung pwede ma-observe, either constructive or destructive. Okay. So you can try for both conditions. Kapag yung M na lumabas mo is not integer, then hindi pwede yun. Kailangan laging integer. Okay? Okay. So dito, in this case, constructive si interference. Now, if we move yung R1 at to 17 meters, okay, we solve again for the path difference and type of interference. So again, same lang yung steps. Ngayon, R1 minus R2 will be 1 meter. Okay. So nagbago to, magbabago rin to dapat. Okay. So 1 meter ngayon yung path difference. We plug in our values. And if we try now, yung constructive interference condition, makuha nating M. So 1 to, 2 yung lambda. So M equals 1 half. Right? So, again, hindi siya integer, so hindi siya constructive. So, dapat magiging destructive. Again, it's either or. Okay? It's either or naman. So, ngayon, if we try yung condition for destructive, so meron ulit tayong M plus 1 half times lambda. Okay? So again, R1 minus R2 is 1. Tapos, meron tayong lambda na 2. So, Sm plus 1 half. 2 naman to. So, what we will have, M will be, meron tayong 1 over 2, right? Minus 1 half. Itong 1 half malilipat doon. So, or M equals 0. So, in this case, integer yung M. For the condition na destructive interference. Kaya, destructive din yung interference. Okay? So, when you solve for M, kailangan maging integer for that condition para yun yung sagot natin. Okay? So, pinapakita ko lang dito na kapag integer si M sa destructive condition, meaning destructive yung interference. Kapag nangyari yon, yung M mo, using the constructive interference, hindi siya magiging integer. Okay? Kaya automatic, it's the other one. Okay? So, ganun lagi. Pwede yung i-test both. Kung saan naging integer si M, yun yung magiging interference point. Okay? Okay. So now, let's move on to Young's double slit experiment. Okay? So ano ba to double slit na to? Bakit siya famous? Bakit siya important? In this experiment, we have a source S0 of monochromatic light. Okay? Ngayon, itong monochromatic light, so again, single color, single frequency, coherent. Okay? Kapag pinapass through natin to a slit, so slit is any very small hole, right? This will produce now a cylindrical wavefront. So bakit kailangan natin ipapasa isang slit? Kasi before nung slit, planar wave, di ba? EM waves are planar waves. Okay? Meron tayong planar monochromatic light, kaya mga line yung wavefronts natin. After it passes through this single slit, meron tayong cylindrical wavefronts. Okay? Now, this cylindrical wavefront, isang source lang to. Ipapas naman natin sa double slit naman, sa two slits. Okay, so si S1 at si S2. So this will now produce two cylindrical wavefronts from each source, and makita natin, meron na tayo nung similar interference pattern na nakikita natin kanina. Okay? And kapag meron tayong observation screen dito, tapos nilet natin yung EM waves to be absorbed or to pass through this observation screen, we will see this alternating bright and dark bands of light, which is now an interference pattern. Okay? So there is bright bands where wavefronts arrive in phase and interfere constructively. Okay? And then meron naman itong mga dark bands where wavefronts arrive out of phase to interfere destructively. Okay? So actually, itong phenomenon na to, hindi lang naman to sa double slit experiment. Nakikita rin to during eclipse. Okay? So during eclipse, para karang ding may slit kasi natatakpan ng sort of yung source ng light, which is the sun or the moon. Okay? And may kita natin, meron din tayong itong mga alternate bright and dark bands. Now we call them umbra and penumbra. So umbra means dark and penumbra means not dark yata, basta light. Yun yung light bands. Okay. So actually may interference pattern. So the Young's double slit experiment in a larger scale is yung eclipse. Okay. So meron din ganun. So digging more into these bright bands and dark bands, so yung bright bands, yun yung constructive interference. So again, if we apply yung conditions, alam natin na yung M, okay, should be integer in the constructive interference. So yung mga M equals 5, 4, 3, 2, blah, 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 blah. Okay? And then, dapat dun sa destructive interference sa dark bands, ang true naman is M plus 1 half. Okay, so makita natin yung alternate. If we start from 0, yung may brightest band, sa taas niya will be plus 1/2 and then plus 1. So yung dark band will be just 1/2 plus 0.5 kasi 0 plus 1/2. Okay? And then yung sumunod na light band will be 0 plus 1. Okay? And then 0 plus hindi na pala 1 plus 1/2, so 3 halves. And then 1 plus 1 is 2. And then 2 plus 1/2 is 5 halves, etc. Ganon din dun sa negative side. Okay? So, yun lang. So, alternating light and dark bands. So, now, question. What is the intensity at any point in these two source interference patterns? Because as we will see, as we go further away from the center, yung 0, yung m equals 0, bumababa yung intensity, may nagiging grayish na, hindi na siya obvious na dark and light bands, di ba? Unlike dito, medyo obvious na, oh, ito sobrang bright, ito sobrang dark. Pero dito, parang nag-gray out sila, nag-mix na sila, right? Meaning, bumababa yung intensity of lightness or darkness. Okay? So, we can calculate this intensity using some geometry. Okay? So, yung actual na nangyari when we have this double slit is this. So, ito yung double slit natin. Okay? Say this, they have a distance d from with each other. Okay? And then, yung viewing screen mo is located at a distance capital R from the source. Okay? From the source. Now, if we have these two waves, we use na yung geometric optics na alam natin, mag-draw tayo ng rays. Okay? So, these two waves, so itong wave na to, from the first slit, dito siya. Yung from the second slit, ito naman. So, magpo-produce sila dito ng either a constructive or destructive interference, right? And let's measure the distance from the center to be y. Okay? So, yun yung y. Now, yung R1 and R2, ito yung mga path difference natin. Okay? From before. And if this R2 or R1 produces an angle theta from the normal or from the line perpendicular to it or yung line na parallel sa optical axis. So, ito yung optical axis natin. This one. Right? Kapag may angle theta yan, so using geometry, angle theta rin ito, yung distance, yung angle from the line perpendicular dun sa R2 to R1. Okay? And this will just be d sine theta. Itong length na to. Okay? So, pag pinoneject natin itong angle dito sa line, this will just be d sine theta. Okay? Kulit naman ito. Anyway, so yun yung actual na geometry. However, since in reality, yung R natin, yung viewing screen is very, very, very greater than the slit distance. Okay? So, yung slit distance natin, sobrang maliit lang yan. Like, sobrang magkalapit lang yung slit natin. And yung viewing screen, usually, sobrang mas malayo. Okay? So, in that case, using our knowledge from geometric optics, we can treat the rays as to be parallel na lang. Parang hindi naman sila nag-meet ever. Okay? Hindi sila nag-intersect. And we apply now the path difference. Okay? So, yung path difference, since aligned sila, right? Since aligned sila, yung path difference, so if we subtract R1 with R2, ito na lang yung may iwan, yung d sine theta. Itong part lang na to. If we obtain the path difference. And again, using your path difference equation kanina, it should be m lambda. Okay. So, now we have m lambda equals d sine theta. So, again, we have here a triple equality. Only valid for double slits. Okay? Only valid for double slits. Kapag wala itong d sine theta, yung R1 minus R2 over M equals M lambda, coherent source. Okay? Kapag meron tayong triple equality, valid naman siya for the double slit. Okay? And from that, we can now calculate for the intensity of the bright fringes. So again, we are using here yung constructive condition, right? M lambda lang. So, makukuha rin nating intensity will be of the bright fringes lang, right? Or yung bright bands. So, let's say those bright fringes are at the location Y sub M, okay? From the center of the viewing screen, we have these rays, and we can generalize yung electric fields ng mga bright fringes. So, si E1 will be E cosine omega t plus phi, and E2 will be E cosine omega t. Okay? So, again, E1, ito yung galing sa first slit. E2, ito yung galing sa second slit. Okay? So, meron silang phase angle or phase difference due to their path difference. Okay? So, ano yung path difference kanina? Nasabi natin, yun yung d sin theta. So, due to this path difference, meron ding magiging phase difference yung dalawang waves na to, si R1 and R2. And that is, ito yon yung plus phi. Okay? Now, using principle of superposition, dapat mag-add up lang sila. Okay? But here, we apply also phasors. Okay? So, mas maganda na tingnan natin sa phasor diagram. Okay? So, yung E1, ito yon. So, yung E cosine omega t plus phi. Okay? And then, si E2 is yung cosine omega t. Ito naman yon. Pero, nirotate mo with a phase angle or phase difference of phi. So, this will be this. Okay? So, if we add this using our phasor, so magro-rotate ngayon sila counterclockwise, ito ngayon yung lalabas, yung 2e cosine phi over 2. Okay? And if we apply yung cosine law for this phasor triangle, we get yun din, yung 2e cosine phi over 2. Okay? So, actually, dito rin galing yung Malus law. So, makikita nyo, parang similar tong cosine squared sa Malus law. So, actually, similar tong equations na to. Pero mas safe lang gamitin yung squared form. Okay? So, yan din yung Malus law. So, makikita nyo na yung, kasi kaya yung Malus law, ang nakuha natin doon, intensity rin. Right? Kasi nga, dito siya galing. Okay? So, at any point P on the screen, ito yung magiging magnitude, intensity ng electric field, right? If a constructive yung gusto natin na condition, phi, yung phase difference should be 0, so we get the maximum amplitude 2e. If destructive, then yung phase difference should be phi or 180 degrees. And we also, and cosine phi over 2, that will be 0. So, yung 0 naman yung, mali to. So, 0 naman yung, intensity. Okay. So, maximum intensity and then 0 intensity. Okay. And here we define yung intensity to be the average of the pointing vector S up. So, hindi na natin dinaanan yung pointing vector, but yung pointing vector, siya actually yung similar dun sa C na vector dun sa E cross B. Okay. So, if you remember this, E cross B, yung cross product na to, yung C na to, yun yung actually yung pointing vector. So, usually S din yung ginagamit. So, if we take yung average S magnitude, we get the intensity. So, dun din galing yan. Okay. So, if plug in this, and using I naught to be this one, so let's just say this is your initial intensity, we get your typical Malus law. Okay? So yung Malus law, true din siya for intensities in double slit. So para ka lang din dumaan sa polarizer. Similar lang, okay? So wala namang, ang gusto ko lang i-point out is walang masyadong bagong equation. Ito lang yung kailangan nyo tandaan for the intensity, which is nakita na natin before. Okay? So maximum intensity means kapag yung phase difference, phi 1 minus phi naught is 0, that means constructive. Okay? Kasi nga I naught yung makukuha natin. Kapag pi ito, kapag 180 degrees, then destructive interference. Okay? Kaya din sa polarization, kapag exactly pi, kapag yung, di ba, doon sa polarization, kapag ganito yung polarization ng incident angle, tapos ganito naman yung polarizer natin, nagka-cancel out, wala kang makikitang intensity. Kasi yung difference between them is 90 degrees, which is 180 over 2 or pi over 2. Kaya ganon, meron tayong destructive interference because of that. Okay? So actually, similar lang talaga to sa Malus law. Okay? So nakita na natin yan before. So some applications is of course solar panels. So meron silang tilt kapag nakaharap sila sa sun so that na ma-maximize yung energy or direction ng energy or pointing vectors na nakukuha nila, na-absorb nila from the sun. Okay? So yun yung gusto nating i-maximize. Kaya minsan, nag-a-adjust sila din ng angles for the solar panels para kung depende kung nasaan yung sun. Kasi again, nagbabago naman yung angle ng sun sa sky. Hindi lang siya sa solar panels, ganun din sa mga sunflowers and other phototropic plants, yung mga mahilig sa light. So, ganun din. So, makikita nyo kapag inobserve nyo itong phototropic plants na to, as the sun moves across the sky, sinusundan nila or nagtitilt din yung angle nung kung saan nag-face itong mga phototropic plants na to. Okay? So, harap sila usually sa may direction with the maximum amount na pwede nila ma-absorb. Okay. So, yun yan. Now, we can now relate yung path and phase difference. So, sabi natin kanina, kapag nagbago yung path difference, R2 minus R1, nagbabago rin yung phase difference. Okay. So, actually, ito na yung equation na yun. Okay. This shows that we can relate the path and phase difference. So, yung path difference is constructive. Kung constructive yan, kailangan again integer of multiple integer to. So, we get this path, this ratio, which is just 1. Okay? So, yung path difference na ratio, itong R2 minus R1 over lambda, will be always 1 for constructive interference. Okay? Yung phase difference, ganun din. Kasi ang phase difference will be always 2 pi or full cycle. Okay? 0, 2 pi, and 4 pi, etc. So, if you take the ratio, always 1 din yung phase difference for constructive interference. For destructive, half cycle naman palagi. Okay? So, actually, yun lang yung difference. Yun lang yung magbabago. So, for constructive interference, yung ratio ng path difference and phase difference, always 1. For destructive, always 1/2. That's why we call full cycle for constructive interference and then half cycle or for destructive interference. Okay. Pwede rin full cycle phase shift or no cycle phase shift kasi nga 1. O tapos meron din tayong half cycle phase shift. Okay? And then from here, alam natin na yung 2 pi over lambda is your wave number. Okay, yung K. So dapat alam niyo na to from your 71. So wala namang bago doon. So we also have this equation for path and phase difference. Again, phase difference yung phi, path difference yung R2 minus R1. Okay. And then yung 2 pi over lambda is just your wave number, K. Now, if the material is in the space between sources and P is not in vacuum, then we apply yung mga dispersion and propagation equation natin. Okay? Yung lambda equals lambda naught over N and then K equals NK naught. Okay? So mag-a-apply pa rin naman sila. Okay? Kapag hindi na vacuum. Kapag nasa medium na sila. Okay? So in summary, we have this condition for constructive interference. Okay? Yung path difference is just this, R1 minus R2, and yung phase difference is just this. Again, itong part na to, itong d sin theta, pwede mo palitan ng m lambda or nung R1 minus R2 kasi nga triple equality ito. Okay. As long as constructive interference yung hinahanap. And then for the intensity, we have this. So again, we have a phase difference over 2 or yung plug in natin tong value na to. So, similar lang naman yan. Now, for the condition for maximum intensity, for the or yung bright fringes, we get, dapat, sabi natin, dapat, ano tawag dito? 1 yung ratio, right? 1 yung resulting nung intensity. Ito. Okay. So, para maximum intensity, kailangan yung highest value for cosine squared yung makuha natin, which is yung 1. So, if this is the case, then, etong nasa loob, yung argument ng cosine squared should be multiple integers of pi. Okay? Of pi. And then, we apply some algebra and we get this. So, actually, makuha lang din natin ito. So, yung condition for constructive interference, yun din yung condition for maximum intensity, which nga yun yung bright fringes. Okay? So, again, kailangan nyo lang malaman dito is yung theta, angle where the maximum intensity occurs, and then yung d is the distance between the slits. Okay? So, now, let's apply this to approximate yung location ng bright fringes dun sa viewing screen. Ito na yung mga y, height, or distances from the center. So, the previous condition can be written in terms of this location of the mth bright fringe, y sub m, instead of theta sub m. Okay, so etong theta na to, corresponding siya sa m. Right? Ngayon, we can use just y sub m. Kasi minsan mahirap anuhin yung, isipin ano yung angle. Okay. For this, we use small angle approximation kasi nga we assume that yung viewing screen is very far or from the double slit. Okay. So in that case, theta is approximately tangent theta or sine theta. Using just a bit of geometry, yung tangent theta sub m, yung tangent ng theta m dito, will be yung, ano ba, SOHCAHTOA. So opposite, so kung theta m, ang opposite niya is y sub m, ang adjacent ay r. So we have this y sub m over r, which is approximately sine theta m. Okay? Using yung small angle approximation natin. Then, from here, okay, we now have sine theta m is this. So, yung ym over r, yung tangent theta yung sine theta m over r naman, meron tayo ng equation kanina. Ito. Tapos, i-plug in natin ngayon yung bagong value for sine theta, which is yung approximately ym over r. We get this. Okay. So, this is now yung ym, to yung location or distance from the center of the bright, center of the viewing screen. Okay? R is yung distance ng viewing screen and then D is yung distance between the slits. Okay? So, yun eh. Slit to screen distance, slit separation, etc. Now, if we plot yung ym for various lambda, okay? So, makikita natin itong plot na to. So, yung intensity I versus y, okay? So, para tayong kumukuha na ngayon ng cross-section nung wave, makikita natin yung periodicity ng peaks or no crests. And consistent sila with the alternating bright and dark fringes formed by the actual interference pattern. So, if you plug in yon, makikita natin yung intensity, maximum dun sa center, yung bright fringe, and then maximum at every m lambda. Okay, so for every m lambda, maximum din yung intensity, and dun din natin nakikita yung bright fringes. Okay? So, for example, some examples, coherent sources A and B emit electromagnetic waves with wavelength 2 centimeters, and then you are located at point P, 4.86 meters from A and 5.24 meters from B. What is the phase difference at P between these two waves? So, pwede natin i-drawing, right? So, meron kang point P. So, meron kang source A. And then, mayroon kang source B. Okay? Tapos, yan dito. So, oops, sorry. Meron tayong source A. Meron tayong source B. And then, we are at some point P. So, given yung distance ni RA at RB. So, actually, ito na yung R1 and R2. Okay? Ito na yung R1 and R2. So, ang hinahanap ay phase difference. So, ano yung phase difference? Yun yung phi. So, we just use yung equation natin, 2 pi over lambda. Yung lambda is yung 2 centimeters, yung wavelength ng EM wave. And then, R1 minus R2. Since absolute value naman yan, so we don't, pwede rin RB minus RA. Okay? So, given na yon, so, plug in our values, we get this, 38 pi radians. Okay? Remember, do not forget to convert from centimeters to meters. Okay? Kasi yung wavelength natin in centimeters. Yung point P is in meters. Ayan. Dami namang mali sa slide na to. So, meters yung slide. Ay, meters naman ito. Okay? Ayan, meters. Ay, dami mali sa slide. Okay? Okay. So, ganun lang. Basta plug in our values as long as same yung units. Okay, same yung units. Another example, coherent sources A and B emit EM waves with this wavelength, 400 nanometers. And then point P is 600 nanometers from point A and 800 nanometers from point B. What is the phase difference? So again, plug in, use lang natin yung equation, 2 pi over lambda, absolute difference ng path difference. We get pi radians or 180 degrees. Okay. So that will be for double slit and coherent sources. Now, let's move on sa final interference lecture which is in thin films. So, mukhang hindi obvious, pero thin films, nakikita na natin to since before. Okay? So, yung mga soap bubbles, meron tayo nakikita mga interference effects kung saan meron ding dispersion na nangyari. And these patterns also form on pavement from leaked oil. Okay? So, here, hindi lang intensity yung nagbabago, pati rin yung color. Right? So, meron na ring diffraction or dispersion na nangyari. And these films form these different colors as a result of natural light reflecting off their surfaces. Okay? So, recall, yung reflection and refraction natin, So as light rays hit a boundary of two media with different indices of refraction, merong nare-reflect, merong natatransmit. Yung natatransmit, pwedeng ma-disperse, pwedeng ma-refract. Okay? So how does this work? So consider the figure shown, which is in A, the interference between rays reflected from two surfaces of a thin film. Ito. So kung meron kang thin film, so say soap bubble or yung puddle of gas, right? Or puddle of water actually pwede rin. And then ito tayo sa observer at point P. Okay. So meron tayong incident light in air, magre-reflect siya on the air film interface. Okay, yun yung ABC. And then meron din magre-refract papunta sa point D. Okay. But here inside the film, meron din tayong law of reflection. Yun yung BDE. Okay. Yun yung line BDE. Tapos, since nag-reflect, etong wave na to, magre-refract naman ulit kasi nga air naman to. So, meron ulit tayong DEF na refraction. Okay? So, we have a partial reflection from the film's upper surface, yun yung ABC, and partial reflection, actually, pwede rin naman. From the film's lower surface, yun yung ABDEF. Okay? And both these reflected waves reaches the observer. So, ang tanong, constructive ba to or destructive? So, will we see a bright color or a darker color? Now, we can answer that by considering these waves to be similar dun sa ropes, dun sa 71 natin. Okay? So, we recall yung waves hitting some boundaries using ropes. So, meron kang case 1, if thin, yung source ng wave natin is from a thin rope, magbabounce siya dun sa thicker rope, ano yung mangyayari? Magpo-produce tayo ng wavelengths in each of the ropes. So, meron tayong wave na matatransmit and then meron ding wave na mare-reflect. Okay? But the reflected wave is inverted, which means 180 degrees yung phase difference. Okay? Kapag yung source ng wave nasa thick rope to thin rope, again, merong matatransmit, merong mare-reflect, but this time, yung mare-reflect is hindi na inverted. Upright with respect dun sa source, and the phase angle is 0 degrees. Okay? Kasi pareha silang may crests. Okay? So, yung reflected wave is of the same phase. So, yung density ng rope, similar dun sa index of refraction. So, actually, the higher, ayan, so kung nagta-travel from thicker to thinner rope, that means meron tayong higher refractive index sa source, tapos lower refractive index sa transmitting plane. So, if this is your wave, may matatransmit or marerefract, may marereflect, but the reflected wave has no phase shift. Okay? So, phase difference is 0. Kapag equal yung dalawang index of refraction, so meaning equal din yung thickness ng rope, fully transmitted. Walang ma-reflect. Okay? Kapag naman mas malaki yung nasa transmission plane na index of refraction, so may ma-refract, may ma-reflect, and we have a half cycle phase shift. Yung phase difference is pi. Okay? So actually, nakita nyo na tong ropes before sa 71. In-apply lang natin on a different context. Actually, similar lang yung dynamics nun. Okay? And we recall as well yung conditions for constructive and destructive interference. So, for putting them all together for thin film interference, So, ito yung thin film natin, right? So, we have yung path difference, yung R2 minus R1 sa loob, right? Equal dapat siya sa twice nung thickness ng film. Okay? So, may thickness na yung film. Although, thin film siya, pero sobrang liit lang yung thickness na yon. And then, we apply yung propagation and dispersion of light inside the medium. Okay? Okay? Putting this all together, we have now the following. Okay? So, here we have air, nandun yung source, and then yung thin film natin, and then some surface below the thin film. Okay? So now, consider this reflected light. So kung may source tayo here, tas nandito yung observer, again, half cycle phase shift ito. Okay? Yung sa lower surface naman, half cycle phase shift din. Kasi, film is less than, kapag less than yung NA sa NB, half cycle phase shift. At this point, less than din yung NA sa NB, half cycle phase shift din. So, if we add them all together, so kung baliktad naman, so kung babaliktad, no phase shift, no phase shift, okay? Kasi NB is greater than NA, NB is greater than NA in this interface. So, wala namang phase shift na mangyayari. So, in both cases, no relative phase shift. Okay? And we have the following. So, conditions for constructive and destructive interference. Okay? So, similar lang doon sa path difference kanina, pinlug-in lang natin dito na yung path difference is 2t, and then yung lambda mag-scale lang with the value of the index of refraction of the film. Okay? So again, this is only true kapag, so let us look again the diagram, kapag yung series of index of refraction mo either papalaki or papaliit. Okay? So 1, 1.52 or 2, 1.51. So yun lang yung kailangan tandaan. Okay? Yun lang yung kailangan yung tandaan for thin film. No relative phase shift kapag either ascending or descending yung ranks ng indexes of refraction. Yung pagkakasunod ng dadaanan ng light. Okay? For that, ito yung gagamitin nyo. Okay? Now, kapag nag-iba, kapag ganito, meron kang 1, biglang tumaas, tas bumaba, or baliktad, bumaba, biglang tumaas. Okay? Meron tayong half cycle phase shift naman na relative phase shift. Okay? So, in this interface, NA is less than NB, kaya half cycle yon. At this interface, NB is greater than NA. So, dito naman, no phase shift sa line 2. Same with the sa the other side naman, baliktad naman, no phase shift dito, and then half cycle phase shift dito. So, pag pinag-add natin yung total phase shift, half cycle plus zero cycle, half cycle plus zero cycle, half cycle yung magiging relative phase shift. Okay? Kanina, half cycle plus half is 1 or full cycle. 0 plus 0 is 0, so 0 or full cycle. So parehas ito, either case, no relative phase shift. Ito naman, either case, meron kang remaining na half cycle phase shift. In that case, magbabaliktad na yung equations natin. Okay. So take note, kapag increasing yung index of refraction or decreasing yung index of refraction, ito yung condition, M lambda for constructive. Okay? Kapag yung indices of refraction bumaba tapos tumaas or tumaas tapos bumaba, babalik ta rin nyo lang. Okay? Magpapalit lang sila. Destructive na yung kanina. Okay? Yun lang yun. Yun lang yun. Yun lang yung kailangan yung tandaan. Okay? So, bakit ganon? Bakit nagbabaliktad? Kaya nga, Yung effect nito, kaya siya nagbabaliktad is kapag tumingin ka at different angles dun sa thin film, nag-iiba na rin yung colors na nakikita mo, pati yung intensity. Minsan, yung red kanina nagiging darker red, yung violet nagiging lighter violet because of this. Nagpapalit kung ano yung constructive and destructive. So, nagbabago rin yung intensity nila. So, ganito yung nangyayari for your anti-reflective coatings. Kaya meron tayong mga glasses, right? Na bigla nagiging dark kapag nasa loob tayo kasi nga nagiging less yung intensity kapag tumingin ka at different angles, nawawala yung reflection. Okay. So, anti-reflection implies destructive interference of the reflective wave. So, kung wala kang anti-reflective coating, ito, meron kang reflection na nakikita through the lenses. With anti-reflective coating, nawawala naman yan. Okay? So, makikita natin, mas sumaya siya kasi wala ng anti-reflective coating. And other examples, yung 3D, tawag dito, 3D glasses natin. So, dito naman, constructive naman yung reflected waves. So, gusto mo makonstruct yung waves of all colors at all angles. Okay? Or mirrored sunglasses. Okay, some just few examples. What is the thinnest film of a coating with this index of refraction on a glass? Okay, so yung for which destructive interference of red component can take place by reflection. Okay. So again, reading comprehension. Okay. Coating, siya yung may index of refraction 1.42. So kung ito yung coating, ito yung index of refraction ng thin film. Yung surface, yun yung glass. Okay? So yung index of refraction ng glass, yung surface is yung 1.52. Gusto natin destructive interference ng red component. So yung wavelength ay 650 nanometers. Okay? So N film is 1.42, yun yung coating. Surface, yun yung glass, yun yung 1.52. And of course, nasa air lagi yung source natin, which is always 1. Okay? And then, hinahanap is yung lambda naught or lambda in air, which is 650 nanometers, yun yung wavelength. Okay. Smallest t, smallest thickness for destructive interference. So, ano ngayon to? Increasing, so continuously increasing yung index of refraction. Tama? So, 1, 1.42, 1.52. So, gagamitin natin yung no relative phase shift case. Okay? No relative phase shift case. And yung condition for destructive interference is this equation. Okay? So, plug in our 650 nanometers or N film 1.42. Meron tayong this equation. Saan na yun? We now have this equation. And yung thinnest or smallest t is always at m equals 0. So when m equals 0, we have this minimum thickness. Okay? Okay? So again, reading comprehension, alamin ko ano yung index of refraction ng film, ano yung index of refraction ng surface, tingnan kung increasing or decreasing, or nag-increase then decrease, or baliktad. Okay? Kapag always increasing, ayan, nag-i-increase or nagdi-decrease, no relative phase shift. Kapag nag-increase then bumaba or bumaba then nag-increase, half cycle phase shift. Okay. And then apply yung conditions for either destructive or constructive interference. Kapag thinnest, yung smallest t, smallest thickness, always m equals 0. Okay. Okay. And finally, sa final example, the wall of a soap bubble have about the same index of refraction as that of plain water. There's air both inside and outside the bubble. So what wavelength in air is of visible light is most strongly reflected from point on a soap bubble where its wall is this thickness, and what color does it correspond? Excuse. And then if nag-iba na yung thickness, ano ngayon ulit yung bagong color? So again, reading comprehension, N ng air is 1, ito yung source. N ng film is 1.33, okay? And then N ng surface is again air, which is again 1. Okay? So ito yung diagram natin. So source natin nasa labas, yung film is yung soap bubble, right? And then sa loob niya, air din. So air din yung surface sa loob. Okay? So 1 ulit. Okay? Kailan strongly reflected yung lambda knot? So wait, again, this is a case of tumaas, then bumaba. So half cycle relative phase shift. So yung baliktad yung gagamitin natin. Tapos yung tanong, ano yung tanong? Most strongly reflected. Ano yung most strongly reflected? Okay? So actually for that, since strongly reflected, that means we have a condition for constructive, malito. Mali-mali itong slides nila. Constructive interference. So, dapat constructive. Kasi nga nare-reflect eh. Okay? So, constructive. Constructive yan. Okay? Mali ito, mali. Okay? So, for constructive, ito na yon yung baliktad. And then we try for different values. Alam natin yung T, right? Alam natin yung N film. Hindi natin alam yung lambda knot and M. So, we try different values. Okay? If M equals 0, we get this. If M equals 1, we get this. And if M equals 2, we get this. Now, ang tinatanong lang, strongly reflected in the visible spectrum. Okay? Ang visible spectrum natin is this, 400 to 700 nanometers. So, kapag outside that range, wala na ulit. So, same nung nangyayari kanina. Okay? So, ito, beyond 700, hindi natin kailangan. Ito, less than 400, hindi natin kailangan. So, ito lang yung nagmamatter. Okay? M equals 1. So, only M equals 1 gives this visible wavelength, which is a green light. So, 514, asan yung 514? Ito, in between this range. So, that means green light. Okay? Now, ano naman yung strongly reflected at 340 nanometers? So, again, constructive interference. Di naman nagbago yung diagram. So, half cycle. So, ito pa rin yung condition na gagamitin natin. Try for different values for M. Ano lang yung pumasok sa range ng visible light? Yung M equals 1, which is now orange light. Okay? So, we see here that if nag-i-increase yung thickness ng film, nag-iiba rin yung light na strongly reflected. Okay? And, yun na yun. Okay? So, yun na yun for thin film. So, ang important lang, alamin nyo ano yung surface, ano yung film, ano yung thickness, and then ano yung order. Okay? Ano yung order dito? If nag-increase, or if nag-increase, then bumaba. Ano ba yan? If nag-increase, then bumaba, or nag-decrease, then umakyat, then half cycle relative, baliktad. So, ito yung constructive. Mali ito. Daming mali sa slide na to. Constructive yan. Okay. Kapag full cycle, relative or no relative phase shift, yung nag-i-increase lang lahat or nagdi-decrease lang lahat, baliktad naman. Ito naman yung condition for destructive. Okay? So, yun lang po for your interference. So, here we have discussed the interference in coherent sources, double slits, and thin films. Okay? So, that will be our last lectures. last lecture for optics and for physics 72. So, please answer na lang yung DQ. We will check that on January. So next year na. And ayun, so see you next year. Happy holidays and enjoy the holiday break. Thank you everyone.